Man, I was just sitting in my classroom and my teacher was telling us how the equator works. And she says it's a line that goes straight across the earth, right? So then I had a question for my teacher and I said, why are places near the equator hotter? Why are they hotter, Mrs. Teacher? And she answers, on the Earth, the equator receives more sunshine than do the poles. This is due to simple geometry of the Earth's curvature. A given amount of sunshine in a beam falling on the equator, which points directly at the sun, has a much more intense effect than the glancing rays spread over a much larger area of the curving surface near the poles. And then my teacher has the audacity to show me this little graphic. And she says, the equator is hottest when the sun is hitting it at 90 degrees. Oh, okay. And then she says, it's cooler at angles. So 45-degree angles, 30-degree angles, it's coldest. Let's just throw it in there, 60-degree angles. You're saying angles get cooler, right? Okay. Keep that in your thoughts, folks. So I go to earth.nullschool.net, a visualization of global weather conditions forecast by supercomputers, updated every 3 hours, and they show me this photo. Sea surface temperature on the globe. Now that looks very similar to what my teacher showed me, right? The sun is hitting the equator at 90 degrees. That's why it's hot, right? This all makes sense. Oh wait, no it doesn't, because last time I checked, our Earth had a tilt. Remember, our Earth is tilted 23.4 degrees. Is everyone just forgetting about that? So let's see what they got wrong. They're saying the equator is like this. The sun is hitting the Earth at 90 degrees. That's what they're saying. But wait, we're going to take the tilt into account because we're not idiots. And we're going to make this little diagram. So now the equator is exactly where it should be, at 66.6 degrees. We subtract 23.4 from 90, and then we get 66.6. So I'm looking at this graphic that I had to make myself because people are forgetting that the Earth is tilting for some reason. And I wonder to myself, if my teacher is saying it gets cooler at angles, and I assume you believe that 66.6 is an angle, right? I'm thinking, shouldn't it be 90? Shouldn't our equator be like this, Mrs. Teacher? I mean, according to your logic, our equator is in the wrong place. Remember you said it gets cooler at angles? I don't know, but you should certainly know. Shouldn't the equator look like this? That's what you're telling all your students. But it doesn't make sense because our Earth is tilting, remember? I mean, you should know that the Earth is tilting 23.4 degrees. I mean, doesn't that make a big difference? It means our sun rays are not hitting the equator at 90 degrees. It means they're hitting it at 66.6 degrees. Why is that happening? Is that little ray of sun just hotter than the other rays of sun? I mean, it seems like it's hotter than the 90-degree sun ray. But according to you, that should be the hottest one. So I'm confused. Help me out. So I'm going to now simulate a 90-degree angle on the equator, even though that this doesn't happen in real life. I'm just going to do it and see what happens. So in this photo, I simulated the angle. The sun is hitting the equator at 90 degrees. But wait, another problem is introduced. Shouldn't Antarctica be melted if it's hitting it at 90 degrees? It doesn't make sense. Look at this image and tell me if it makes sense to you. How does that make sense whatsoever? I don't know. All I know is that my teacher, Mrs. Teacher, is really contradicting herself, and I think we should hire a new teacher, possibly someone who knows that the earth is tilting. That's a start. I mean, shouldn't our equator look like this, Mrs. Teacher? Because the red line is 66.6 degrees, and the purple line is when it hits 90 degrees. And you say it hits it at 90 degrees. I mean, that's the only way your model makes sense. So I think, maybe there's something wrong with the whole globe model. Maybe. So I go back to earth.nullschool.net, I click on the flat earth model, and would you look at that? Something that actually makes sense, right? The sun moves around the equator in a circle, just like we predict it to, just like it measures perfectly. I mean, look at this photo. Doesn't this explain everything, folks? I mean, it's absolutely absurd if you still believe the equator is possible on a globe. It doesn't make any sense. It contradicts itself 2 or 3 times. And what are you going to say? It's refraction? Look at this photo again and tell me why this little sun ray, the 66.6 degree sun ray, the one with the green question mark, why is that so powerful? Why, Tell me. Can you tell me? Is it refraction? Are you going to start looking up on Wikipedia why that is? Because I'll sit and I'll wait. And then why is the blue question mark sun ray not as hot? I don't know. Wouldn't it be the exact same? I mean, look at this video again, right? This is how it measures. Remember? Remember what nullschool.net is? A visualization of global weather conditions, updated every 3 hours. So it seems like what's occurring in real life isn't what's occurring with the globe model in real life. Feel like it's not synced up real well. And that's why I'm calling BS on the equator on the globe.